Welcome to the presentation of the paper A System Dynamics Model for Supply Chain Risk Assessment in Power Plants. This is part of the 38th International Conference of the System Dynamics Society. My name is Eduardo Munive. I am one of the authors of this paper. The first author is Dr. Sahar Al-Mashakbeh, and the third author is Professor Khurshid Khan. We have prepared a poster for this, the presentation of this paper. Now I'm going to go through the different elements of the poster to explain our research. So first of all, it's important to consider that the risk assessment activity, which is part of the risk management process, should be considered a strategic tool or a strategic approach to facilitate the creation of stronger, more resilient operations and supply chains. Operations can be dramatically disturbed if critical hazards may occur. These kind of hazards can be, for example, internal issues happening in the organization. They can be factors happening externally to the company but influencing the organization, for example, devaluation at national level, higher level of inflation, the appearance of disruptive technologies that can affect the business, natural disasters, human conflicts. These hazards, if they happen, they could affect the delivery of products or the delivery of services, and in the end, then they may affect or increase costs in the company, or reduce profitability, or even damage the reputation in the long term for the company. So the long-term performance of a company might be affected if these hazards may occur. In addition to this problem, it's also important to consider that risks do not exist in isolation. It's possible that different risks in different parts of the company, in different functions of the company, may be interrelated, and it's sometimes very difficult to understand these interrelationships. So assessing risks can be a complex problem. In addition to this, we understand that internal aspects of the company may change with time as well, and also the business environment may be also very dynamic. This is, for example, the case of the energy sector, which is the sector that we are analyzing in this paper. So the risk assessment activity is actually a very complex system. So the aim of this research is to develop a system dynamics model to assess key risks affecting the long-term strategic performance of supply chain in the energy sector. The model that we have developed is trying to capture the key interrelationships existing among various risks affecting the supply chain performance. And we are also considering that the organization exists in a dynamic business environment. So this factor needs to be taken into account when carrying out a risk assessment exercise. The methodology that we implemented was validated with 2 case studies of power plants. The problem was defined and the data was captured through an extensive literature review, but also through carrying out semi-structured interviews. These were applied into 2 case studies in power plants, and also we have 18 people who participated in these case studies and who had positions related to risk management responsibilities. As a result of this exercise, it was possible to identify 13 key risk indicators, and these were classified and quantified. Exponential weighted geometry mean and analytical hierarchical process were tools applied in order to help us to quantify the risks. Although this paper is not covering this aspect, we have in the list of references the papers in which we discuss this part of the research in more detail. A modeling methodology was, in very broad terms, shown here, developed and implemented. So the first element of the methodology, stage of the methodology, was to define the problem. Then we determine the system boundaries by identifying endogenous and exogenous variables and parameters affecting the system. We constructed causal loop diagrams in order to allow us to understand the interrelationship among the risks in the risk assessment system. And then from there, we translated those causal loop diagrams into stock and flow diagrams, and we tried to quantify the interrelationships existing between the elements of the model. We tested and validated the model with the case study of these two power plants, and we simulated different scenarios in order to see how this risk assessment tool could be used to provide recommendations to managers in the power plant in order how to plan better strategic plans in the future. So some of the 13 key risk factors that were identified consider aspects related to, for example, the supply chain risk as an indication of the level of supply uncertainties and supply certainties. We also have elements like technical risks, power plant efficiency, risk of fuel management, energy production risks, the risk of operational and maintenance costs of power plants, some of the endogenous variables. And we also have exogenous variables like policy and regulation and inflation rate, which are out of the control of the power plant. From this exercise, we start to build a causal loop diagram, and we can see, for example, here in the screen, the causal loop diagram, how, for example, supply chain risk is a measure, an indication of the supply chain uncertainties and supply chain certainties. And for example, supply chain uncertainties depends on different external aspects. For example, it could be the global economy, inflation risk, regulation, the risk of strikes. While the supply chain certainties may be related to, for example, understanding the conditions in the company, which are related probably to technical risks, that this can be well understood if maintenance is carried out properly and you can keep records of your maintenance procedures. And then supply chain risk go back to influence and affect the conditions in the power plant, which at the end also we are going to influence the performance of the power plant in terms of the production risks, efficiency of the power plant, and maintenance cost, and in the end the availability of energy supply. From the causal loop diagrams, we then developed the stock and flow diagrams, stock and flow model. We use any logic for this, and then we can see here some of the key stocks that we identify, like supply chain risks, power supply availability risks, the risk of operational maintenance cost, efficiency risks. And from here we were able to simulate a few scenarios in which we were able to understand how the risk assessment of the power plant is affected by these supply chain risk factors. As a result of this, we should be possible then to understand, for example, in the case how inflation risk could be mitigated internally within the company, and in that way this could be, we will be able to have a more to inform management in order to support their strategic decision making when they take decisions in terms of procedures or strategic plans. So what we can see is by using system dynamics to support the development of risk assessment tools or risk assessment models, then it's possible to support strategic decision making. So in this way, the implementation of system dynamics modeling could be considered a strategic analytical tool for companies. By doing this, then companies should be able to monitor better their risks, to be able to identify ways to reduce operational maintenance costs, to be able to enhance the availability production time of their facilities to produce, to generate energy, and to be able to improve power supply availability. This, by implementing system dynamics modeling as part of the risk assessment approach, then this should be able to benefit and make more efficient the development of risk management policies, risk mitigation plans, operational maintenance procedures, and in general long-term strategic plans, not just related to supply chain, but it's possible to apply the same approach, the same modeling approach to other functional areas of the company. Not could be, for example, marketing or and customer perspective, financial perspective, innovation perspective. And this is something like a future research we will try to do to make the application of this methodology that we have applied for supply chain into other functional areas of the performance of the power plant. So this approach is different from the traditional risk assessment approaches, in which the dynamic element of operations and the dynamic element of the influence of the business environment is not considered. So this is why this approach is more complete in terms of considering these changes in time, which are in the internal operations of the company, but also in the external aspects of the business environment of power plants. And with this, we finish the presentation of our poster and our paper. And thank you very much for your attention.